And so now, without further interruption, today's forum will be given by Ann Rossington, Chemistry Lab Manager. Ann will be telling us today about the work she has been doing extracting natural dyes from flowers. Take it away, Ann.
Welcome. So yes, this is sort of what I've been doing this summer, collecting natural dyes. So this first part is just a quick run through. This is just sort of what got me interested in dyes in general, was ice dyeing. So here's just a cool time-lapse video of how ice dyeing works. And so it pulls the dyes down at different rates. So the colors almost separate out. Gives you some nice, really cool effects. So here's just still pictures of the different melting stages and then final product. So these are called TLC plates. So this shows you essentially different colors that are in a dye. So that's why they can separate out, and you can get multiple colors from an individual dye color. And I get all of mine from Dharma Trading Company. So these names are Dharma Trading Company's names, just in case you're interested at all. And so here's just a couple examples of ice dyeing that I've done. And this is the real, so those fabrics are one dye. So, and that's the black dye that I did. So you can see how it separates out in the ice, almost like a TLC plate. So that's what I thought was pretty cool and interesting. All right, now we'll get into the real stuff. So fabric. What I use, there's two types of fabric, animal and plant fibers, which are natural fibers. So a lot of unnatural fibers like polyester, synthetic fibers, sorry, will not work very well. So what allows these plant fibers to, or natural fibers to work, is that they have a site on them, which actually causes a bond between the dye and the fabric to make it a permanent dye on there. So these are two definitions, kind of. So a mordant, I actually put onto the fiber, and this just helps a dye become even more permanently fixed onto a fiber. So for this, I used borosilicate glass and deionized water to avoid contaminations, because I'm using compounds that we find in our nice hard Alfred water. So these I can make in big batches. I soak fabric into a solution and then just air dry it. So I'm not rinsing off whatever I've impregnated it with. So that's a mordant. So a mordant is on a fabric. That's what you have to remember. And then there's the modifying bath. So that is actually during the dyeing process, and this can alter the hue on your dye. And so these are some of the compounds that I used. And the cool thing about this is, so say the copper, the iron, the aluminum, those can actually be used in a pot. Like you can use the metal pot, and that is enough to impregnate your dye bath and get an alteration in color, which is kind of cool. And then citric acid, you could use lemon juice. And then both soda ash and urea are bought anywhere where you would buy dyes or a craft store. So, my first attempt at anything. Phlox, they grow everywhere. You can see them on the side of the road. I'm going to say, like June, July, you start really seeing them, and I mean everywhere on the side of the roads. So these aren't necessarily in my garden, but they are in my yard. And they are very tiny flowers, so they were actually quite a challenge to collect because I try to only gather the petal. I try not to get any of the green material in there, again, to try to avoid any type of contamination. I just want to try to get the chromophore out of the flower petal for these ones. So these ones, I used fresh flowers for them. And the first thing I did was an unmodified dye bath to sort of see what colors I could get. And those aren't up here. But this is, so you can see, so remember the modifier is actually in a dye bath. The mordant is what's on the fabric. Now, actually, this was my first one. So these ones, I did not add dye to my modifying bath. This was strictly a dip process. So I dyed them in the raw dye bath. I did not add anything except for water. And these I just dipped into a modifying bath and got this nice range of colors. And like I said, this was my first one. So I didn't quite start taking too many copious notes yet. So these are, my next one was hibiscus flowers. Now these ones, I used fresh flowers as well. And I heated it up slightly. I don't bring any of these flower dyes to boiling because I noticed it seems to almost degrade the dye. And all these are, they were the two different groups there, the no modifier and the citric acid modifier. They were all stuck together, so I make nice big dye baths and stick all the fabrics in there together. So for the first one, no modifier, you can see that I actually do get a range of colors. But then for the citric acid, you can see it's all a hue of pink. So that's a very good indicator that these are more pH dependent. So if you change them from acidic to alkali or alkali to acidic, they're gonna change a hue. So this is another proof of concept of that. So KOH is potassium hydroxide, that is basic. And then, so I did them with the alkali bath and then dipped them into either aluminum or copper. So this is another proof that they're kind of pH dependent because the hues are the same, it's the same color, but I guess the hues are different if you adjusted them with a modifying bath, or a mordant, I'm sorry, a mordant, different mordant fabrics. And now this one, I used dry flowers, so you can see it didn't make too much of a difference between, if you really look at the copper, I guess, you can really see that it didn't make too much of a difference between the dried and fresh flowers. Irises. So for this, I will say I specifically used that nice dark purple one that's up there. But I have a lot of irises, so hopefully my next step is doing them all. So this one I did dehydrate the petals and store them because I had very few of these really nice dark flowers. So I dried them and stored them, and then once I had all of them that had bloomed for the year, I soaked them in deionized water again. And then I stored them in the fridge. And actually this one, I did not heat at all. This was completely passive absorption of the chromophore for the dye baths. And so here's sort of, you can see the dye bath and the color that I got on each. I have another slide which will show you what was what, essentially. And this was one of my favorites, the range of colors I got from it. And this one too, I think I can actually get much deeper colors in this if I collect more plant material. And a quick side note, I do have my folders back there that have actually have these fabric swatches and stuff in them if anybody wants to check them out. Next, I did some poppies. So these ones I just collected. If anybody has poppies around, you know, they don't last for too long, and then the petals all fall off nicely into your garden. So I just I collected these as they fell off into a jar of deionized water, and same thing, I just sort of stored that in my fridge for a couple weeks as I was collecting flower petals that had fallen. And these ones I did heat slightly to get the dye out. And then I filter out the plant material from it. And each of those 4 modifying baths, I stuck all of those fabrics into the bath. And it's the range of colors I got. And I'll reiterate this, I'm always rinsing these out with DI water because our hard water actually can change the hue of it as you're rinsing it out. Staghorn sumac. So this is sort of like the phlox. This grows around here naturally, and it's all along the creek beds. So I dehydrated these berries, and then I stored them for 4 months. I can't really remember why or what, but that's what I did. And so these ones I really heated up in water. Like I was simmering them. They were basically boiling, and I heated them for 5 hours. And it's just I noticed that these seem to be able to hold up to more heat than whatever is causing the dye in the flower petals. So there's just a, where are we at? All right. So this is the same thing. I put all the fabrics into the modifying baths. You can see up there in the corner the different colors baths that you get. And then these ones gave me pretty intense colors, I'd say. I know the pictures don't necessarily do them justice, but you can see the nice range of colors that I get from them. And last but not least, some nice apple heartwood. So I made sure to get all the bark off this. Bark has a lot of tannins in it, and it's a brown color. It is a very strong dye, but it's a brown color. So I make sure to get all the bark off of a live branch that I've gotten. I don't want a dead one. So then I shaved off as much as I could. If you see that one right there, you can see the little shavings. And then they were cut into little discs by the wonderful carpentry department here. So, again, I'm using deionized water and borosilicate glass to avoid contamination. These ones were a little bit harder to extract, as I'm sure you can imagine, hardwood. So if I go back, actually. So you can see the first one, how light it is, and then how it darkened up quite a bit. So these ones, like, I brought these to a rolling boil, and I boiled them for about 5 hours. I let them all cool together overnight, and then the next day when I came into work, I brought them back up to a boil and let them go for another about 5 hours. And if the raw that I've labeled in the middle, the raw, that is just the dye and water. So that's, I guess, what your natural dye would be for that. And same thing here, I got very vibrant colors that stuck very well to the fabric with this. Now I will admit, I did something a little bit different here. So after I did the baths, heated them up slightly with the fabric in it, I removed the animal fibers, especially wool. If you've ever gotten it too hot, you notice it starts to break down and disintegrate. It's no longer a nice stringy thing. So I took those out, rinsed them out, just let them air dry, and I stuck the plant fibers back in, and I brought those very close up to a boil. And I noticed the plant fibers actually gathered up that dye much better with higher heat. And so plant fibers can stand up to higher heat, animal fibers a little lower, or they sort of start to disintegrate. So I got a lot of ideas from this Chemistry of Natural Dyes, just sort of how to get going. This Wild Color book is an amazing book to get you sort of going. And I used it almost opposite. Stuff I found in here, I tried not to do in my presentation. I tried to find colors that I liked in my garden and then essentially see if it worked out. So my next step in life for this is this summer, I'm hoping, since I have a nice procedure now for getting the dyes, I'm hoping to this summer go back, collect more materials so I can have bigger dye baths, get more intense colors. I'm pretty sure I like the procedure I have, but I'll just essentially redo it. And then we have lovely instruments in chemistry. We have like an LCMS, a gas chromatograph, we have HPLCs. So my next step is to actually find out what chemicals or chromophores are in the dyes, which can be challenging because there's lots of derivatives and fun stuff. But that's where my next step is. So please, questions, or if you want me to go back to something. I know it was a lot of the same stuff with only minor differences, so yes.
When you put the iris leaves in the refrigerator, were they in the water? Or were they just wet?
Oh, yep, when I stored them, yes. That was after I had already soaked them in the water. So yes, it was the dye that did not have the flowers in it anymore. It was strained out. And yes, the dyes seemed to stay fairly well in the refrigerator.
When you use different kinds of mordant, like soda ash, whatever, did you mix the fabric with those different kinds of mordant into one modifier? Or did you did, you could mix them all together?
Yep, so yes, so the mordant fabrics, yes, I put all of them into one modifying bath.
All together?
Yep, I put them all together. So I do admit, the first sort of few I did, yes, I separated them all out. I had tiny little baths for each individual one. But then I did a big group of them, and I noticed that didn't change the color, so I said, let's do it all at once.
That changes me completely, thank you.
Yeah.
While I bring the microphone over to Ian, one question I have, did you try to change the pH before dyeing cloth to see if the color would also change before that?
Yes. Like it will change the modifying bath. Is that what you're asking?
Maybe, no, like did you take the colored stuff and alter the pH after the fact, before you dyed it?
I mean,
go back and forth between colors. Like if you acidify the basic, there's a change, and then if you put base back in, it changes back.
yes, you can adjust it yes, you can adjust it.
Hi. You really jumped right in with content, and I love that. But I'd like to know your background. Are you a chemist? Are you an artist?
Oh, yep. So yes, I am the chemistry lab manager here. So chemistry, biology. That's my background. Yes.
And she's an artist. Do you have any idea why the iris in particular was so influenced by the modifiers in ways that the other ones were not?
This is just an assumption so far, but yes. So iris flowers have anthocyanins in them, and there is an abundance of derivatives of that. And those are all differently affected by the mordants. So the real thing is I have to figure out what derivatives are in there. But that's my assumption as to why I got such a range of colors, is because it has so many of the derivatives in it.
Great presentation, Anne. Beautiful colors. I really appreciate that. And I like the way you were showing the variables, like mordant versus the modifier. I really appreciate that. My comment was more like suggestions. I'm pretty sure you have empirically nailed the color and the hue you are getting. You may want to measure pH and temperature. That will narrow down some of the variables. You can measure them. With the lab, you have access to all of them.
Mm-hmm.
I was definitely surprised after boiling so long. The color in the water is pretty impressive. I would definitely be curious to know what is in it really. So you could perhaps use spectrometers. So it'll be nice to know what finally ended up after boiling, what botanical species or what is the molecules left there really. That'll be really nice. But they're pretty vibrant, colorful. So thanks anyway. I learned something. You know?
Awesome. And I will admit, I do have pH measurements and temperature for a lot of stuff. I honestly just thought there'd be a lot of numbers that nobody really wanted to hear.
Hi, really lovely work. I wanted to ask, did you notice any kind of a trend in the ability or willingness of the different fibers, whether they were animal or plant-derived, to take up dye with
Yes.
the plant-derived dyes?
I definitely did. Actually, I noticed silk was the best. So honestly, a lot of these ones that you're seeing, like the ones on top that are extremely vibrant, like that, is silk. So I did notice the silk overall was the best for sure. Wool was a bit, it depended. And I think that honestly had a lot to do with because wool has a lot of oil on it. So I think that had a lot to do with it. But then the later ones I noticed adding extra heat to the plant fibers for sure got it. Because cotton was actually quite hard to get a nice vibrant dye on it.
Can I ask a follow-up question about preparing the fibers? Did you have different scouring processes depending on what you're using?
Nope, so these were sort of how I did the modifying baths as well. I put the entire, so I had chunks of fabric and I put, so I had cotton, bamboo, hemp, silk, and wool. No, I put those in a group. So I had a nice big 2-liter beaker. Yep, and I just stuck them in there and boiled them all away and then air dried them.
Hi, really good presentation, thank you. I'm wondering if you went on then to dye anything like clothes or make any art out of these dyes that you have created?
Not yet. I do have all my color swatches back there, so I do have an idea to make some, almost like a collage thing out of them. I have not done that yet or had time to do that yet. But no, as of right now, I was just sort of experimenting with them. I hope after I get it down nicely, then yeah, I can start actually dyeing clothes and make some art with it.
Along those kinds of lines, as either part of your planned phase 2 or perhaps a phase 3, do you have any plans because some of the things that you've used as either your modifiers or mordants aren't exactly easy to get when you're not a chemist. Are you planning on using anything that you can get at, say, Wegmans or Walmart or Lowe's? That way then there can be even an at-home procedure for people who want to make their own dyes, either for art or clothing.
Yep, so, well, first, I guess you can get glass. You don't necessarily need nice borosilicate glass, any glass jar. Then the metals, get a copper pot, get an iron pot, get an aluminum pot. You can do it all in those. And then the citric acid, use lemon juice. And then the other two, urea and soda ash. I guess I should put that. Like I said, they're readily available Walmart has them. So it is everything that I did. There is an at-home application. It was just I used DI water and borosilicate glass just to avoid contamination, so I could see what was going on.
Cool. Other questions for Ann? Well, if not, please join me again in thanking Ann for a fun and colorful talk.